Hi, I'm Chem's best friend. Today's video will be about hydrates. If you are interested in private tutoring lessons, the information is on the screen below. All right, let's learn more about hydrates. You probably are introduced to hydrates right after you do some mole-to-mole calculations. And what are hydrates? Let's go to my screen. So, a hydrate is any compound that has absorbed the water molecules from its environment and included them in its structure. Most common types of hydrates are inorganic hydrates. So, what are they? So, water molecules in inorganic hydrates are only loosely bonded to the compound. There is no chemical reaction involved. It's very easy to remove these water molecules by heating. And when the water is lost, and you are left with an anhydrous compound, that means with no water, all the water is removed. So here is an example of a hydrate along with the name. So here we have a formula. So here is the formula of a hydrate. And we call it copper 2 sulfate pentahydrate. And the reason is, remember, sulfate is a polyatomic anion, has a 2- charge, so that copper has to have a positive 2 charge. So we have a copper 2 sulfate, and then it's pentahydrate because pentagon 5, so there's 5 water molecules per 1 copper sulfate. So here is another one, cobalt 2 chloride hexahydrate. Here's this one. And here is beryllium sulfate tetrahydrate. I would like you to notice something. Let's go and look at our copper sulfate pentahydrate. So if we write copper sulfate, and then we write this dot, and then we have this 5 water, I want you to notice that this is a 1 to 5, and this is a mole to mole ratio. So for 1 mole of copper sulfate, we have 5 moles of water. It's a mole-to-mole ratio. It's very important to remember that. All right, let's look at another example quickly here. So here is an example of copper sulfate, and the reason I chose it is I would like you to have a look. When it's a hydrate, it is this very gorgeous dark deep blue color. But when all the water is given off, when it's anhydrous, you have this gray powder. So when you do a lab in a class, many times you will have a visual clue of when it's a hydrate, when it's anhydrous. It's really interesting. Not all hydrates do that. Okay, so here is some properties of copper sulfate, but I think you want to solve some problems, right? You probably have some homework problems and want to say, what do I do? Well, let's solve some problems. Here is one of our problems. So let's do this. We have a 16.4 grams of hydrated calcium sulfate, and it's going to be heated until all the water is driven off. And the calcium sulfate that remains has a mass of 13.0 grams. Oh, it reminds me of something. How do you know all the water is given off? That might be a lab question that you're trying to answer, where here's what's going on. If you heat it over and over and the mass is not changing, that means all the water is gone. That's how you know. It actually was an AP question a few years ago. Okay, so we want to find the formula and a chemical name for this hydrate. Let's start. So remember, the mass is 16.4 grams. What's 16.4 grams? That's my calcium sulfate and water. Yes? And then we're going to subtract 13 grams. What's 13 grams? Well, 13 grams is only calcium sulfate. So if we do this subtraction, we're going to have 3.4 grams of water was given off. So water, our H2O. Okay. So that's step 1. Now we're going to change mole to mole. Remember, the numbers in front are mole to mole ratios. That's what we're trying to find out. So let's do that. So we have 13 grams of calcium sulfate. And then we also have, we're going to write over here below, 3.4 grams of water. And these are mass. These are masses in grams. We need to change it to moles. So let's go. So we're going to have times 1 mole of calcium sulfate. And if you do your molar masses, look at the periodic table, add them up together, you should have 136.15 grams here of calcium sulfate. And we do this calculation, and you should get 0.0955 moles of calcium sulfate. All right, let's change the same thing. Let's do the same thing with water. And the water is where 1 mole of water is, what is it? 18.0 grams of water. And we do this calculation, and we have 0.189 moles of water. All right, so we're closer. We do have a mole-to-mole ratio, but they are not whole numbers. So I'm going to do second step in a different color. We're going to divide by the smallest number. Remember, these are mole-to-mole ratios. I can do the same thing with both, and the ratio stays the same. So I'm going to divide by my smallest number. So 0.0955 here. And right here, this will be 1. And this, when you plug it in the calculator, you get 1.98, which is about 2, which is great. So now I can write my formula, right? So I'm going to have a formula then is calcium sulfate, and it's 2 water molecules. So it's for 1 mole of calcium sulfate, we have 2 moles of water, right? And the name is calcium sulfate dihydrate. There you go. That's it. Let's do one more. One more problem. Here is problem number 2, and it's a little bit different. We have a hydrate is determined to be 45.43% water and 54.57% cobalt 2 chloride. Find the chemical formula and the name for its hydrate. And here's the hint. You are given percent. What's going on? This is percent composition by mass. By mass is the key here. So what can we assume to make our calculations easier? Well, I think the first step is this is important, we're going to assume 100 grams. If we assume 100 grams, what's 45.43% of 100? Oh, now these the percentages become our masses. So we're going then to have 45.43 grams of water, and we're going to have 54.57 grams of cobalt 2 chloride. And we're going to now do the same thing we did. Now we have masses. We have to change it to moles, because remember, in the formula we have mole to mole ratio. So let's do it for water. Times 1 mole of water is 18 grams. I'm going to use my also sig figs. And when I do that, I'm going to have 2.524 moles of water. All right, let's keep going. And right here, we're going to use our periodic table to get our molar mass. So 1 mole of cobalt 2 chloride is 129.83 grams. And that will give me 0.4203 moles. All right, so we have a mole to mole ratio, but it's not whole numbers. So we're going to divide by the smallest number. The smallest number is 0.4203. So I'm dividing by 0.4203. This becomes 1 mole. And this, if you plug this in, it will become 6.00. So this is 6 moles. Great. So my formula is then cobalt chloride, and I'm going to put 6 H2O. So for 1 mole of cobalt 2 chloride, I need 6 moles of water. And what's for 6? Oh, hexagon. So it's cobalt 2 chloride hexahydrate. And then actually, you can quickly check. Remember what we did before when we were looking at the example? And here it is. This was used before. You saw this before, so we know we are right, and we actually saw it with numbers. All right, this is it. I hope you can see that solving problems with hydrates is not that hard as long as you remember to change everything to moles because it's a mole to mole ratio. Thanks for watching and see you next time.